Hi, I'm Michael Yosley, and today we're going to be doing external flow over 2D bodies with a flat plate example, and this is for design of aerospace experiments. So as you can see, we have Workbench pulled up in Fluent, so let's go over there, and we've got our geometry. So we'll pull up the geometry that we've got going so far. We already have the wind tunnel pre-built. And since the wind tunnel is pre-built, all we got to do is put our structure inside. So let's zoom in to our test section here. We're going to zoom in a little more so that we have our blockage ratio at that 10%. Make sure that it's not affecting our results. Over here on the left hand side, we're going to go to draw. We've already got it set up in inches. Rectangle. And this is just going to be a simple flat plate. We're going to make it 0.3 high and 0.1 thick. That way we can make sure our ratio is correct. Blockage ratio. That looks like that's not. We're using modified drag. This function helps us out when we do stuff like this. Get that up to that 0.3. Alright, now we'll generate that. Modeling. We'll zoom. Well, let's start doing our surface from sketches first. So we'll do surface from sketches. Now we'll select everything in here. Then we'll zoom it back out. Now it looks like we're going to have to go back over. We'll select all of these different points. We should be able to just select this. There we go. Click apply. Okay, now that we've got everything selected, we should be able to generate our surface. That covers everything up. Now we go to surface and we need to make sure that this is fluid, because this isn't the actual wind tunnel, this is the area going through the wind tunnel. So surface body. My surface right here is where we need to change this to fluid. Okay, generate. And now what I'd like to do is create my name sections in this portion. The name section, we're going to name the inlet. We're going to go up here and select edges, inlet, generate. And we're going to need to do this with the outlet as well. Back up here. Outlet. And we need to select edge again. Apply. And generate. Now we're going to zoom in. We use our tool for name sections. I'm going to do this for the bottom of our flat plate. There we go. Tools. Oh yeah, we got to generate every time. Top. Select edge again. I'm going to do the tip for the front. We're going to name it the tip and the tail just because that's what we did for the other structures that we put in there when we had the airfoil and hemispheres. So just to keep everything consistent rather than name it the front or back. Okay, generate. I'll zoom back out, just take a look at everything, make sure it all looks good. Alright, click generate one more time, minimize that, that'll bring us back here. Go into our mesh. Make sure that geometry is set up for 2D. I had issues with that before. Causes a lot of problem when you try to run your setup and solution. So this may take a second. Okay, we've got our mesh pulled up. Now what we're going to want to do is make sure that all the name sections transferred over. Looks good. Geometry, coordinate system, mesh. We're going to change this to mechanical. And our element size, we're going to want 1 every ½ inch, and this goes by feet. So what we're going to want to put in here is 0.041667. That'll give us every ½ inch. We want to turn on adaptive sizing. And everything should be good to create our mesh. See, we're at 5% down here, so there we go. Now we've got our mesh applied to the entire surface. So we'll minimize that. I need to update this, so just right click, update. That lightning bolt should change to a check mark as soon as this show progress is over. There we go. Now you can double click on setup. Alright, so we've got the setup populated here. We're going to switch that to double precision. So that's what we're going to want for our experiment here. Okay, now we've got our setup pulled up over here. Go into models. Go to energy. You just want to toggle this to on. And then next we're going to want to change this viscous SST K omega. So you're going to double click on that. It's going to pull up this window. Going to change that to K epsilon, and everything else will stay the same. Click OK. And we can minimize everything else in models. We don't need to do anything else with that. You can check materials just to make sure that it says air. Aluminum is what ours is going to be made out of for this experiment. Boundary conditions, we need to go in here. And this is why you have to create those named areas before, so that you have inlet labeled here. This is where we can change our velocity for the speed of the air in the wind tunnel. Now remember, this is the velocity going into the settling chamber, so we need to edit it so that it's achieving the speed that we want in the test section. For this one, that speed is going to be 3.2927, and that's in meters per second. Everything else we leave the same. Apply, close. Internal, we don't change anything there. Outlet, this should default to atmospheric pressure, but we're just going to want to pull that up and check. Okay. Gauge pressure 0. Okay, everything looks good there. Close that. Now our boundary conditions are all set. Just scroll down. We don't need to change anything else in this setup portion. The solution. Methods, we're going to need to change this to simple. I think I'm going to have to move that to my other screen to click, scroll down to the bottom. Okay. No, we just need to set that to simple. Okay, now I clicked initialization, standard initialization, scroll down, everything there stays the same, click initialize. Now click on run calculation. Number of iterations. We're going to do 100 iterations for this. You can put that up a lot higher for more complex cases, but 100 should work for ours. And at the bottom of this, there's a button that is not populating that says calculate. So we click calculate. It says the solution must be initialized before calculation can start. So you'll click yes. Let's see if we shouldn't need the task page anymore. There's our scaled residuals that are populating. As you can see on the bottom, it's going out to 100 iterations, just like we set. You can also go into monitors here and change the residuals that set your tolerance for this. We left it the default. Okay, calculation is complete. And now we can get the information that we want from this. We want a pressure contour and interior surface body. That will give us the actual fluid on the inside. If you do wall surface body, it's on the outside and won't factor in what you've put inside your wind tunnel. So compute, save and display, close. So that's the contours of your static pressure. Let's make sure we name that. Okay, there we go. And we had to name that because we're going to have a second contour for velocity. Velocity magnitude, again, interior surface body. Compute, save and display, close. So we have there you can see our flat plate that's inside the wind tunnel. Next we're going to go to path lines. Now this one's got a little more complexity to it, so again, we want interior surface body. Line style, our steps. You're going to want to lower your steps so that you can see what's going on. I'll put it at 50 just so that you can see the difference. Compute, and then we'll display it. See, that looks pretty similar to a contour when you just have it with that many steps in it. So we're going to lower it quite a bit. See if we can get something that's a little more readable. And we'll zoom in after this so that we can see what's actually going on with these path lines. See there, it's populated, and that doesn't give us the information that we need to be getting from these path lines. So I'm going to put this number at something like 5. I think 8 and 4 gives us a little better picture. And this will take a second to run these calculations back through there. All right, now we'll close out of our drop-down menu. We'll see if we can zoom in to see what's going on in the middle here, see if this is a little better. Still not great, so let's see if we can make some more adjustments to that. And click on this path lines one again. Change our steps to 20. Interior. Save and display. There we go. As you can see, you're getting a little better path lines every time. A little better idea of what's going on around this flat plate. So if you just keep messing with that, you can get a better picture, and you can also, okay, everything's already saved. When you go back here, you can also edit that once you go see your results. And that's pretty much it. That's how you do the flat plate. My name is Michael Yosley. Thank you for watching.